Okay, so graphing it. So I take my graphing calculator or whatever I have to graph, it doesn't matter, and you're just going to trust me that I'm going to tell you that the graph looks something like this. The graph looks something roughly like that. There's a good enough picture. So then I see from the picture that it has origin symmetry, and because it has origin symmetry, it has to be odd. And so that's the way you're going to do it, that you're going to have to answer the question first, that you're going to have to do it in a different order than what the question in the homework is asking. The question in the homework is asking symmetry or asking even, odd, then symmetry. You're going to have to do the whole thing first, then type in the answers. But graph it, then answer. Same thing on the next one. Get a graph in whatever manner you can get it in. So x to the 4th minus 7x squared. That graph looks something roughly like this. So we note that it has y-axis symmetry, which makes it even. And that's how we're going to do the problem. So you click on View an Example, they're going to do such hard stuff, and we don't want to do hard stuff. Okay, we're going to work with some graphs some more. And we're going to pull in some stuff, some information from last section and this section, just looking at some graphs. Okay, and so this goes on and on. We got an A, it goes A through N here, working on this graph. Okay, shown below is the graph of a function. For function f of x, find or answer the following. Domain. Now I got a little lazy here. It's understood to do that we have arrows on either end. So we think back to last section, and domain was left x to right x. And in this picture, it's going left forever to right forever. And so the domain is negative infinity to infinity. Range. That was lowest y to highest y. On the low side, it's going down forever. On the highest side, it's up there, and it looks like it's maybe just a little bit above 1. I know you can't particularly, hopefully you have these notes in front of you as you're listening to these videos, but it looks like it's a little bit more than 1, but we'll just call it 1. It's probably a little bit more than that, but we'll just call it 1. Again, anytime when you're reading from a picture, it's a guess. And maybe it's a little bit, it probably is a little bit more than 1, so maybe I'll call it 1.2. And so negative infinity to 1.2, square bracket, because it's on that 1.2 line. X-intercepts and y-intercepts, that's easy enough. X-intercept, x equal -2, -1, and 2. Y-intercept, y equal 2. If I was being a perfect math teacher, I would say the x-intercepts were the points, -2, 0, -1, 0, 2, 0. And I would say that the y-intercept is the point 0, 2, but I'm not a perfect math teacher. That's good enough. Find the zeros of f. So here's a new word. Zeros are essentially the same as x-intercepts. So there's a new word for today, zeros. The reason why I say essentially is this. If I was being a perfect math teacher And for the x-intercepts, the perfect math teacher would have said the points, negative 2, 0, 1, 0, 2, 0. Those are the x-intercepts. They are points. And if I was being perfect, I would say negative 2, 0, negative 1, 0, 2. Zeros are just numbers. And so the zeros are just negative 2, negative 1, 2. So there's the small difference between x-intercepts and zeros. X-intercepts are technically points. And so if I was being perfect, I would list both coordinates, negative 2, 0, negative 1, 0, and 2, 0. Zeros correspond to the x-intercepts, but it's just the x values. Intervals where the function is increasing. Well, it's increasing on this first part and this third part over here. So it's increasing on the left forever, so negative infinity, to it looks like roughly negative 1.5. And again, that's an estimate. It's a guess, but close enough. And then again, from it looks like 1 to a little more than 2, maybe 2.2. That it starts rising again right about there, which is 1, and then right about there, which, maybe 2.2. Again, ballpark. Now, in the homework, it's on a nice, neat grid, so you don't have to guess. Here, a rough guess. Decreasing, just in the middle here. So here's where it was increasing. INCR stands for increasing. Decreasing, we'll highlight that in red. And DECR, it looks like it's decreasing on about negative 1.5 to 1. You're just using the x coordinates, just the x coordinates. And then constant on the very end. So that's up here where it's constant. And so that looks like maybe it's happening at roughly 2.2 to the right forever infinity. Number at which, or it says number at which it has a relative minimum. Language here, number at which. In general, relative minimum is my low point, which looks to be maybe like 0.8, negative 3. Estimate, estimate, estimate. It doesn't look like it's clear. Maybe it's at 1. And again, these are just estimates. I think maybe it's at 1, but someone else said 0.8. Who cares? So we'll say 1, negative 3. Then the number at which is my x-coordinate, x equal 1. Going on, got the same function there. Then it says relative minimum. Again, the low point was 1, negative 3. And so the actual minimum is the y-coordinate, y equal negative 3. You got to be really careful about that language there. The number at which is your x-coordinate. The minimum value or maximum value, as the case may be, is your y-coordinate. F of 1. This is the y-coordinate of the point, whose x-coordinate is 1. So I go and look, and it looks right about there, and maybe it's negative 3. It's estimating. On the homework, it's on a nice neat little grid so you don't have to estimate. If I give you something like this on a test or quiz, I would accept anything that was close to -3. The values of x for which f of x equals -2. And so this is saying the x coordinates of the points whose y coordinates is -2. So this one's pretty easy to see. It is just one of them, just right there. And so we've got the point 0, -2. Oh no, and then right here, which looks like maybe 1.5, -2. And maybe right there, which maybe that's -2.5, -2. But I've got 3 of them. And again, estimates. And so it would be x equal -2.5, 0, and 1.5. And again, anything that would come close to those numbers would be good. Is f even, odd, or neither? That's the same thing as saying, talk about the symmetry. When we ask about even, odd, or neither, what we're doing in this class is saying, talk about the symmetry. Look at the picture, talk about the symmetry. And this has no symmetry. Doesn't fold across the y-axis, doesn't fold across the x-axis. It certainly doesn't have that double flip from the first quadrant to the third quadrant. No symmetry, so neither. Is f of 1 positive or negative? And the easiest way to do that is just to find f of 1. F of 1 is the y-coordinate of the point whose x-coordinate is 1. So I go and look here, and again, it looks like that would be about -3. And so it would be negative. Now, that's the easiest way to answer it. But what they're getting at is note that the point is below the x-axis. And that's why, so f of 1 is negative. When a graph is below the x-axis, its values are going to be negative. And that's what they're trying to get at here. But the easiest way to answer that particular problem is just to figure out what the value is and say, well, that value is negative. But the reason why, and we can't see the graph anymore, and I'll bring the graph, we can't see the graph anymore, but I'll move it up and go back to the old page. There's the graph again. That when we get to -1, it's below the x-axis. Then the last thing we got here, for what values of f of x is f of x greater than 0? And that's the same thing as saying, where is the graph above the x-axis? Negative below the x-axis, above positive. So right here, it looks like it's above the x-axis from -2 to -1, from here to here. From -2 to -1. And then again, from it looks like right about here to, and then forever to the right, infinity. So greater than 0 is above the x-axis, so from -2 to 1, and then again from 2, and forever to the right, infinity. And that's where we will end this video.